We present our virtual try-on method, VOGUE. In the virtual try-on task, we are given an image of a person and an image of a garment of interest. Our goal is to synthesize the person on the left wearing the garment of interest from the right image. This try-on result is produced by our method. Notice how our try-on result preserves identity details, such as hair, while also transferring qualities of the try-on shirt, such as sleeve length, color, and neckline. The goal of our virtual try-on method is to achieve photorealism while maintaining fine-grained control. Here's a try-on result from the current state-of-the-art method, StyleGAN. Although current state-of-the-art is trending in the right direction, the try-on images are low resolution, blurry, and sometimes contain artifacts. Since our goal is photorealism, we looked for methods capable of producing high-resolution images. We were inspired by StyleGAN, which has been used to synthesize faces. It produces high-resolution results that look almost indistinguishable from real images. Because of this, we build our method off of StyleGAN. As an overview of how StyleGAN works, it generates high-resolution faces from a latent vector. A key insight of StyleGAN is that it maps the latent space Z to an intermediate latent space W to enable better disentanglement. The generator starts at a low resolution and progressively grows to generate high-resolution images. To apply StyleGAN to the try-on problem, the naive approach would be to train StyleGAN 2 on fashion data. However, we also had to make changes to the architecture to enable fine-grained control in addition to photorealism. The first change we make is to condition the network on pose. This disentangles pose from the style code and enables our network to generate the same style of clothing for people in different poses. The other change we make is generating segmentations at each resolution in addition to RGB images. This will enable us to isolate regions of interest via masking during the VOGUE optimization method. Here are some examples of pose condition results from our network. We can generate the same style of clothing across different poses. We can also generate different styles for the same pose. Here we show examples of RGB and segmentation outputs from our network. The segmentations have 9 labels. We can generate accurate segmentations for any pose. Once we have our pre-trained conditional StyleGAN 2 network in red, we build an optimization network on top of it to achieve try-on. Our optimization method takes in latent representations of a pair of images corresponding to the person and try-on garment. We use the weights from our pre-trained network to learn an optimization. We run the optimization for 2,000 iterations and then end up with the final try-on image. Next, I'll go into detail about how the optimization works. The optimization method takes in 2 latent vectors corresponding to the try-on pair. The latent vectors are mapped to intermediate latent vectors W as in StyleGAN. We introduce interpolation blocks for each resolution. The interpolation blocks transform both the person and the garment intermediate latent vectors into style codes, and then interpolate between the style codes to get a unique combined style code at each resolution. These new style codes are given as input to the pre-trained conditional StyleGAN 2 network to produce a try-on image. The interpolation coefficients Q are what we optimize over. We learn cues, a different set of cues for each style block. We use the output segmentation of the try-on image to mask out identity in the try-on garment from the try-on image. This goes into the loss function and is compared with the masked garment and identities of the original images. In addition, the loss function takes in a pre-calculated term M, which measures how localized the changes are to our region of interest. Our loss function has 3 terms: a localization loss, a garment loss, and an identity loss. Next, I'll show results on generated images from our method. Notice how the neckline, hemline, and sleeve texture are preserved when transferred. Similarly, the identity of the person, including hair, skin color, and pose, are preserved. Our method is also able to synthesize skin consistent with identity when transferring a shorter sleeve garment. Notice how our method is able to transfer across different poses. Our method is also able to achieve photorealistic try-on for different body shapes. We can also look at try-on for pants. Our method is able to synthesize pockets, buttons, and zippers, even though they weren't in the original image. To apply our try-on method to real images, we add an additional projection step. We use an optimization to find the best latent vector that produces images perceptually similar to the images we want to project. We project into the Z+ space, which means for each image, we learn a latent vector for every style block. We run this projection optimization for 2,000 iterations for each pair of images. Here we have real images that we want to project. On the bottom, we show the projected images after optimization. Projection is able to preserve color and shape well, but isn't able to replicate patterns or high-frequency details as well. Improving projection is an area of future work. Here we show results for our method on real images. Notice we're able to transfer the shape and color of the garment across body shapes and pose, while maintaining identity. Finer details such as the quality of fabric and tie are lost due to projection. We're able to transfer clothes across any pose. Notice again that we can synthesize skin correctly, preserve identity, and transfer many of the garment details. Here we show comparison with state-of-the-art. The first two columns show the person and the try-on garment. The third and fourth columns show results of two state-of-the-art methods, CP-Viton and StyleGAN. And the last column are results from our method. Notice how the two baseline results are blurry and have artifacts. In comparison, our results are high resolution and are able to correctly synthesize color and shape of the garment while preserving identity. Here we show several try-on results. Notice the variety in pattern, sleeve length, and neckline. Improving projection is a direction of future work. In these examples, you can see the loss of detail, for example, in the sequence on the bottom row. We would also like to apply try-on to videos. Thank you.